Welcome back to Networking Explained. In this episode, we're tackling a piece of infrastructure that quietly powers almost every fast website you visit, the CDN or Content Delivery Network. The basic idea is simple. The web feels fast everywhere because your content isn't actually coming from one faraway server. It's being copied strategically closer to you. To see why that matters, picture a user in Tokyo trying to reach a server in New York. Every single request makes an 11,000-kilometer round trip across the Pacific, and physics sets a hard floor on how fast that can happen. Distant users wait noticeably longer, and that one origin server is stuck handling the entire planet's traffic on its own. So the natural question becomes, what if a copy of your content already lived near every user? That's exactly the problem a CDN sets out to solve. So here's the idea in one sentence. A CDN is a global network of servers that keeps cached copies of your content close to your users. That single shift unlocks three things at once. Content gets served from nearby, so it feels fast. Your origin server does far less work because most requests never reach it. And you inherit built-in scale and protection from the network itself. To make that concrete, think of how a global retailer actually operates. They don't ship every order from a single factory on the other side of the world. They stock warehouses near you, so popular items go out from down the road. A CDN works the same way. The origin server is the factory, edge servers are those local warehouses, cached content is what's already on the shelf, and the result your users feel is simply lower latency. Only the rare, uncatched request has to travel all the way back to the origin. Here's the shape of it on a map. Your origin, the real server, sits in one place, but it syncs its content out to edge nodes in Europe, the US, and Asia. So when someone in Berlin loads a page, they're talking to the EU edge, not crossing an ocean. Texas hits the US edge, Tokyo hits Asia. One sync from origin, then short trips for everyone after that. Now, those short trips come in two flavors. A cache hit means the edge already has what you asked for. It just hands it back, no questions, no detour to the origin. A cache miss is the first time someone asks. The edge has to go fetch it from origin, keep a copy, and serve it. Slower once, but fast for everyone who comes after. So, which things actually belong in that cache? The easy wins are static assets, images, video, fonts, your CSS and JavaScript bundles, downloads, anything that looks the same for every visitor and rarely changes. Dynamic content is where you tread carefully. Personalized dashboards, live data, banking pages, caching, those can leak one user's view to another. The usual move is either skip the cache entirely or use very short TTLs. And that brings us to TDOL, time to live, which is just a number saying how long the edge can hold onto a copy before checking back with the origin. You set it based on how often the thing actually changes. A logo might sit happily for a year, your version CSS bundle for months, blog images for a few days, and an API response maybe just seconds. The trade-off is always the same. Longer TTLs mean faster pages, but potentially stale content. Shorter ones keep things fresh, but cost you more trips back to the origin. Now, speed is the headline feature, but a CDN actually earns its keep in a few other ways too. Yes, lower latency comes from serving content out of edges close to the user, but at the same time, your origin server is doing far less work because most requests never reach it. You also get a kind of built-in DDoS shield. A massive distributed network can soak up attack traffic that would flatten a single server. And when a post goes viral at 3 in the morning, the CDN just absorbs the spike. No scrambling, no new infrastructure. That security angle is worth sitting with for a moment. A CDN puts hundreds of hardened servers between attackers and your origin, so a flood hits the edge, not your one real machine. TLS gets terminated close to users. A web application firewall filters out bad requests early. Your origin's real IP stays hidden, and bot and rate limit rules are already baked in. Speed and security from the same network. And you can actually see all of this happening with a single curl command. Ask for the response headers on an image, and the story is right there. Cache control says it's good for a year. Age tells us this copy has been sitting at the edge for about a day. And CF cache status hit confirms Cloudflare served it directly. Your origin never even heard about the request. Now, if you've worked with reverse proxies or load balancers before, a CDN might feel familiar. And that's because it kind of is. A reverse proxy gives you one gateway in front of your backends. A load balancer spreads traffic across servers. Both typically live in a single location. A CDN takes that same idea and stretches it across hundreds of edges worldwide with caching built in. And in practice, they stack. Users hit the CDN first, then a load balancer, then your reverse proxy, and finally your app. Before we go further, let's clear up a few myths that trip people up. A CDN doesn't replace your server. Your origin is still the source of truth. The edge just holds copies. They're also not just for big players. Free tiers from providers like Cloudflare make them practical for small sites too. And no, not everything magically speeds up. Only what's cacheable. Dynamic, per-user content still needs thoughtful cache rules to behave correctly. Which brings us to the genuinely hard part, cache invalidation. You ship an update, but users keep seeing the old version because the edge is still happily serving its stale copy. There are 3 common ways out. Cache busting, where you version the file name. So a new build is literally a new file. Explicit purge calls that tell the CDN to drop specific items right now, and short TTLs for content you already know changes often. With the mechanics out of the way, let's put names to the players you'll actually run into. Cloudflare is probably the most common starting point. Generous free tier, strong security story, fastly leans developer-friendly with near real-time purging. CloudFront fits naturally if you're already deep in AWS. Akamai is the original enterprise giant. Bunny is the budget-friendly favorite, and Vercel and Netlify bake a CDN right into their hosting platforms so you barely think about it. So, before we move on, let's tie everything together. A CDN is really just one simple idea. Keep copies of your content close to the people asking for it. A cache hit means the edge answers instantly. A miss means one trip back to origin, and then it's cached for everyone after. TTL is the dial you turn to balance freshness against speed. And remember, this isn't only about being fast. You're also getting scale and DDoS protection along for the ride. So if you're actually setting one up, a few habits will save you real pain. On the do side, cache your static assets hard. Version your file names so a new deploy busts the old cache automatically. Set thoughtful cache control headers and serve everything over HTTPS. On the avoid side, don't cache anything personalized. Don't forget to invalidate on deploy. Don't slap one giant TTL across your whole site, and don't leak your origin IP. That defeats the protection you just paid for. If you want to keep going from here, the Networking Explained series covers the rest of the stack a CDN touches: load balancers, TLS, reverse proxies, DNS, and of course, the CDN piece itself. And remember, a CDN only shields the edge. Your origin is still the source of truth, so if you want to lock that down properly, SSH hardening mastery over at Dargslan.com is the natural next step. Before we wrap up, I'm curious about your setup. Are you actually running a CDN in front of your site yet? Cloudflare, Fastly, CloudFront, something else? Or is your origin still taking every request directly? Drop it in the comments. It's always interesting to see where people are on that journey. And that's CDNs, hopefully a lot less mysterious now than when we started. If this clicked for you, stick around and subscribe because there's a whole Networking Explained series breaking down the rest of the internet's plumbing the same way. Thanks for watching, and I'll see you in the next one.